Welcome back, everybody. Today we're going to be talking about position, velocity, and acceleration. And just like we've been doing the rest of this chapter, since it's day 2, we're just going to go through 3 AP questions. And these happen to be all calculator, so make sure you have your graphing calculator with you as we work through these. Okay, so for number 1 here, this is from the 1999 exam. A particle moves along the y-axis with velocity given by this function v of t for time greater than or equal to 0. So the first thing we want to know is in which direction, up or down, is the particle moving at time t equals 1.5 and why? Now, I know if I want to find whether I'm moving up or down, that's going to depend on whether our velocity is positive or negative. So since I've got the velocity function right here, I'm going to evaluate it. So I'm going to find v of 1.5, and we're going to use our calculator. So let's see. 1.5 times the sine, of 1.5 squared, and I get that's approximately 1.167. Now remember, AP typically goes to 3 decimal places unless it's otherwise specified, so that's the standard I always use for these problems. So I know this is approximately 1.167, which I also know is greater than 0. So since v of 1.5 is greater than 0, the particle is moving up. Okay, and we're done with part A. Okay, so for part B, it asks us to find the acceleration of the particle at time t equals 1.5. And then it's going to ask us if the velocity is increasing and why or why not. So really, if they're asking if the velocity is increasing, they're asking us if that is speeding up or speeding down. Or speeding up or slowing down, excuse me. So we know we're speeding up if the sign of acceleration and velocity is the same, and we're slowing down if they have different signs. So first things first, let's go ahead and find acceleration at 1.5. We know that's the derivative of velocity at 1.5. And now here, since it's a calculator question, I'm going to save some time. Instead of calculating that derivative by hand, which we could do, we would have product rule and some chain rule, I'm just going to use my calculator to calculate this. So if you remember, if we go to math and then 8, we get our derivative here. So what I'm going to do is the derivative with respect to x. I'm going to type in my velocity function, so I have x times the sine of x squared. And I want to evaluate that at x equals 1.5. So again, we're getting the derivative of velocity, which is going to be our acceleration, and we're evaluating when x is 1.5. And so we get negative 2.049. Now, since I know velocity at 1.5 is greater than 0 and acceleration at 1.5 is less than 0, the velocity is going to be decreasing. So the velocity of the particle is decreasing at t equals 1.5 because, let's see if I'm in there, v of 1.5 is greater than 0 and a of 1.5 is less than 0. So they have opposite signs, so it's slowing down. Okay, for part C, it says given that y of t is the position of the particle at time t, and that y of 0 equals 3, find y of 2. So what they're asking us to find is the position at time 2, right? So that's our new position. So we know our new position is going to be, I'm going to write a general function here. So our position at any time t is going to be our initial position, which is 3, plus the displacement. So we know displacement is the integral of our velocity function, right? So it's 3 plus the integral of 0 to t of v of x dx, right? We know that this integral gives us our displacement. So in general, the new position is equal to our initial position plus displacement. So now, if I want to find y of 2, I know that's our initial plus the integral from 0 to 2 of our velocity function. And again, here I'm going to use my calculator. So I have 3 plus, and we use math 9. There's my integral from 0 to 2. And we're going to plug in our velocity function. So x times the sine of x squared dx. And we get a new position of 3.827. Okay, so for the last part, now we want the total distance traveled by the particle. So now remember, we said to get the total distance traveled, we're going to integrate the absolute value of our velocity function. So I'm going to do the integral from 0 to 2 of the absolute value of v of t dt. And again, that's just going to be an easy thing to put in our calculator. So math 9, we're going to 0 to 2. We're going to use our absolute value, and then x sine of x squared dx. And so our total distance traveled is 1.173. And of course, if we had units in our problem, we would use them in our answers, but we just happen to not have units here. Okay, let's look at another problem. This one's going to come from the 2003 AP test. Similar setup, we have a velocity of our particle, and again, we're given an initial position. At time t equals 0, the particle is at position x equals 1. Okay, so now find the acceleration of the particle at time t equals 2. So again, this I'm going to use my calculator to figure out. So acceleration, a of 2, is just going to be equal to v prime of 2. And again, I'm going to use my calculator. So I'm going to do math 8. I'm taking the derivative with respect to x of my velocity function. So I'm being careful with my parentheses. And I'm evaluating that at 2. So I get 1.588. Now it asks us if the speed of the particle is increasing at t equals 2. Again, here's where we have to compare our acceleration and velocity. So I'm actually going to need to calculate velocity at time 2. So let's see, negative 2 plus 1 times the sine, t squared 4 divided by 2 is 2. So I get negative 2.728. So since these have opposite signs, I know the speed is decreasing. So it's decreasing at t equals 2 because a of 2 is greater than 0 and v of 2 is less than 0. Okay, so for part B, now I'm going to find all times t in the interval from 0 to 3 when the particle changes direction, and we need to justify our answer. So we know it changes direction. We need to find when v of t equals 0 to start. Okay, Now, since I've got a calculator, I can go ahead and graph my velocity function to find the zeros. So let's see, y equals, I'm going to put in my function. Oops. And I'm going to graph. I'll probably have to change my window. I've got an old window from something else. And let's see, we're looking specifically between 0 and 3. So I'm going to just change my x max to be 3. All right, so I know that I'm going to be 0 at this point here. So second calc, 0. And I'm going to find my upper bound. And it looks like my time is 2.507. So t is approximately 2.507. Okay, so now I need to do my sign analysis here. And so I need to verify that it actually changes direction. So from 0 to 3, and we have 2.507. Now, when we look at our graph here, I know to the left, so from 0 to 2.507, velocity is below. So I'm under, so that's minus. And then it changes to above the x-axis, so it's positive. So it does actually change direction there. So I know that it changes direction at this time. So the particle changes direction. And because it says to justify, I'm writing out in words what's going on. So changes direction at time equals 2.507 because my velocity, v of t, changes from negative to positive at that time, 2.507. Okay, so for part C, total distance traveled, this is a nice easy calculator question. We know that to find the total distance traveled, we're going to integrate the absolute value. So from 0 to 3, the absolute value of v of t dt. And again, for the AP test, I would always recommend writing this integral first. So don't just type it and put your answer there. They're going to want to see where did that answer come from. So always make sure you write down the integral first, and then you can put the answer that you get from the calculator. So we're going to do our integral from 0 to 3 of the absolute value. Our function was the opposite, x plus 1, times sine of x squared divided by 2. Get out of there, and dx. And then we wait for it to come up. Okay, and we get 4.334. Okay, sorry, I had to pause it there because I had a visitor. At any rate, let's go on with part D. So this is asking, during the time interval from 0 to 3, what is the greatest distance between the particle and the origin? So we want to know either to the left or to the right, what's the greatest distance? So it asks us to show the work that leads to our answer. So now, we know from part B, we already know where the particle changed directions. So now, we're going to use that information to actually find the position at our time equals 2.507 and at time equals 3. So first, we need to consider a function for our position. So I'm going to call position S. So we know S of t, the final position, is going to be equal to the original position, which up in the problem here, they told us at time 0, the position is 1. So position at any time t is going to be my original position plus the displacement, which we know is the integral of velocity. So plus the integral from 0 to t of our velocity function. So that's going to give us the position at any time t. So I know I'm traveling to the left on my first interval, and then I start traveling to the right. So I want to see at what point am I furthest from the origin. So let's go ahead. We know where we are at s of 0. That's at 1. Let's calculate s of 2.507. So we get 1 plus the integral from 0 to 2.507 of the x dx. We're going to go to our calculator for that. Actually, I want to do 1 plus math 9. So 0 to 2.507. My velocity is the opposite of x plus 1 times the sine of x squared divided by 2 dx. So negative 2.265. So that's telling me essentially that I'm 2.265 units to the left of the origin. So now let's see where we end up at s of 3. We're going to use our same position function. So 1 plus the integral from 0 to 3 of our velocity function. So let me pull this. Let's see, from 0 to 3, opposite of x plus 1 times the sine, sorry about that. All right, sine of x squared divided by 2 dx. And I get negative 1.197. So I'm still to the left of the origin. Okay, so that tells us then the greatest distance between our particle and the origin. Let's see, between the particle and the origin is going to be this 2.265. So again, all that negative means is that we're to the left. So that's when we're furthest away from the origin. All right, we've got one more problem left to do here. It's going to be another calculator problem. Okay, so again, we've got a particle moving along the x-axis. We're given its velocity function, and we're given its initial position, x equals 0, or x equals 8 at time t equals 0. So part A, acceleration of the particle at time t equals 4. So again, we're going to use our calculator to take the derivative of velocity when t equals 4. So again, that's going to be our math 8. I'm not even going to bother computing the derivative by hand because I know the calculator can do this for me. So the derivative with respect to x of the natural log of x squared minus 3x plus 3. And we're doing that when x is 4. So we're going to get 0.714. And that's it for part A. Again, we don't have units, so we'll just leave our answer without units. Okay, for part B, we want to find all the times in the open interval which the particle changes direction, and then we want to know where it travels to the left. So if I want to know where it changes direction, I first have to find out where it's equal to 0. And I'm going to use my calculator for that. So I'm going to go to y equals, clear out what we had, and I'm going to put in my new velocity function. Let's see, I'm on the time interval from 0 to 5, so I'm going to change my window. And it looks like we have two values here. So we're going to do second calc. I'm going to find our 0. I'm going to go to the left here, so I get my first one first. So now my left bound, I'm going to make sure my y value is above 0. It's positive. I'm going to hit enter. For my right bound, I have to make sure it changes to negative. and I get a 0 of 1. Well, the 0 is at x equals 1. So t equals 1, and then we'll do calc 0 again to get our second one. Now for this one, my left bound is going to be negative. I want to make sure that's a negative value there. My right bound, switch till it becomes positive, and I get an x value of 2. Now, I can see on my calculator that my velocity is negative on the interval from 1 to 2. So I know I'm traveling left on that interval. Okay, so changes direction. At time t equals 1 and 2. And then the particle travels to the left on the interval between 1 and 2. And I know that because v of t is less than 0 on this interval. Okay, and then the last part, we're going to skip part D because that'll come up later on in this chapter. So now for part C, we want to find the position of the particle at time t equals 2. And again, remember the position, so S of t, it's going to be our initial position, which we have right here, x equals 8 at time t equals 0. So it's 8 plus the displacement, which we know is the integral of our velocity function. So if I'm finding S of 2, it's going to be 8 plus the integral from 0 to 2 of our velocity function, which is going to give us, if we go back to the calculator, 8 plus math 9, 0 to 2, natural log of x squared minus 3x plus 3 dx. Okay, and that's going to give us 8.369. Okay, for the new position. So that's it for position, velocity, and acceleration. We have one more topic left in this chapter, and then it'll be test time before break.